part B of firing, and if Marcos, you could come in and take an image of the inside of the kiln. The work we have stacked on top of each other, you could put it next to each other, you could put it inside each other because there's no glaze on it. And we'll fire the kiln up to about 1860 degrees again. That is cone 06. In an electric kiln, we have a programmable face here. You program it all in. But also, if you could come in here and look, Marcos, we have something called the thermocouple. And the thermocouple, it's sort of like thermal, like thermometer, measures the amount of heat in the air of the kiln. So when that thermocouple measures 1860 degrees or so, it's time to turn it off. When it goes off, it will look like this. We have another kiln here that's been sitting here since last semester. So this is called bisqueware. You could tell it's bisqueware for this clay. It has a little bit different color. It has a little bit of a ring to it, a little thud. And this is like a red clay flower pot in that it will absorb the water and will absorb the glaze. And then finally we got a surprise. We have another kiln here that has some work left from last semester. This is actually Shania, who's in the beginning class. So in a low fire, you could get bright, colorful work. In a high fire ceramics, which is the type of clay we normally use in glazes, the colors are more, let's say, more of a masculine palette. You could get blues and browns and greens because it's fired up to 2,380 degrees. So most colors are burned away. So Marcus is going to follow me outside. We're going to show it down that way. All right. So we're going outside. This is the kiln patio. This is the car kiln here. And again, this was left from last semester. So we have a whole kiln load of work from spring. The kiln posts. And this is the gas kiln. The gas kiln is how we normally fire up to 2,380 degrees. And you can see this is sort of typical of the work. There's blues, there's browns, something like that. All right. So in the glaze kiln, we're going to fire to cone 10, and cone 10 means it's 2,380 degrees Fahrenheit. We go through the same process of loading the kiln, except because the glazes are covering the work, and basically it's glass, we can't put them close to each other. So I always put it about a ½ inch or ¼ inch away. And we have two types of firing. We have something called an oxidation firing. That means the kiln gets plenty of oxygen and it burns clean and free. But in order to get sort of change the glazes, let's say from glass to like diamond-like, we do something called a reduction firing. And what reduction firing means is we reduce the amount of oxygen. And when you reduce the amount of oxygen, the fire still has to burn, so it pulls one oxygen molecule from the glazes and it changes the color. So reduction firing is a little more difficult to achieve. Marcos is a great technician, he's mastered that, and hopefully next semester when we're back here on campus you'll be able to get the reduction firing. So let's go back to the temperature. So again, this is 2,380 degrees. So what we're trying to measure, and like we showed you, this also has a thermocouple on the inside, which is like a thermometer. Maybe you go inside, Marcos. So the thermocouple measures the amount of heat in the kiln, but we're not concerned with the amount of heat. We're concerned more with the amount of heat being absorbed by the clay. So we have to put these in. These are called pyrometric cones. These are 3 different types of clay that will melt at a specific temperature. The middle one is the temperature trying to achieve. So this is cone 10. Then you have the witness cone, cone 11, that is go too high, and the guard cone, cone 9. So we have a 9, 10, and 11. So it's the witness, the guard, and then the cone. We put the cones in the kiln so it lines up. Can you see inside here, Marco? So it lines up with this opening, which my favorite word in ceramics is called the bunghole. Okay, so we put it on the shelves. It lines up with the bunghole. When we close the kiln and we're ready to fire, this is the bunghole plug. We pull the bunghole plug out, look in with special goggles, and we'll see the pyrometric cones have melted, and they will look something like this. Okay? So this will indicate that it's almost time to turn it off. This was probably fired a little bit too cool. This could have been a little bit further down. But essentially, that's how you measure the heat with the pyrometric cones, not necessarily the pyrometer. And then lastly, as we come over here, this has an electric control, and we electrically control the amount of gas up until it gets to bisque temperature, about 1860. After that, we have to take over, and there's a damper back here, and a flue it's called. And what we do is we adjust the amount of gas and oxygen by moving this either in or out and adjusting the gas down here. I think that's it. So hope you learned a little bit something about ceramics, and keep up the good work.